Hi guys, it's Miss Ladderback, and in this video I'm going to go over how to find the number of protons, neutrons, and electrons within an atom based on the information provided in the element key found on your periodic tables. So I have this worksheet out in front of me as well as my periodic table to the side that I'm going to look at often throughout this whole assignment. So the first half here, I'm going to review what is in the key box on the periodic table. So this first number right here, that 8, represents the atomic number. And the atomic number is the number of protons found in the atom of that element. So in this case, oxygen has the atomic number 8 protons. The O is the element symbol. Then we have the element name. In this case, we're using oxygen. And that 16 tells us the atomic mass. And the atomic mass is the number of protons plus the number of neutrons found in the nucleus of that atom. So here we have 16 is our mass, so that's going to be the combined protons and neutrons that will make that up. So we're going to be using this information to determine the number of protons, neutrons, and electrons found within an atom of a particular element. So what I have down below is fluorine, nitrogen, and sodium. We're going to determine the number of protons, neutrons, and electrons for each of those elements. So fluorine has the atomic number of 9. And it has the atomic mass of 19. I'm going to use both of those numbers to find the protons, neutrons, and electrons of fluorine. So if I know that the atomic number is the number of protons, that tells me how many I need to include in the atom. So here, fluorine has the atomic number 9. So it will have 9 protons. Now, protons are a positively charged subatomic particle. So I'm going to put a plus 9 here. And again, I found that with the atomic number. Now, protons, we discussed in class that protons will equal our electrons. So protons, which are positively charged, are going to be the same number of electrons, which is negatively charged, because in our table of elements, all of these elements are neutral. So we have to have a neutral charge. So our charges have to cancel each other out. So if I have positive 9 plus 9 protons, that means I'm going to have minus 9 electrons. Now, to find the neutrons, that's where things get a little bit more mathematical. If I know that the atomic mass is the number of protons and neutrons combined, and the atomic number is the number of protons, I can rearrange that equation to find the neutrons only. So if I take the atomic mass, which is 19, and subtract it by the atomic number, which is 9, that's going to tell me my number of neutrons, because again, the atomic mass is protons and neutrons. The atomic number is just protons. So if I subtract the two numbers together, that tells me how many neutrons there are. In this case, there are 10 neutrons for fluorine. And since neutrons don't have a charge, they are neutral, so there's nothing to put in there as far as pluses or minuses. We just leave it as a 10. So nitrogen. Nitrogen has the atomic number of 7 and the atomic mass of 14. So I'm going to use these two numbers again to find the number of protons, neutrons, and electrons. So if I know the atomic number tells me the number of protons, that means I'm going to have a plus 7 for my nitrogen. So all nitrogen atoms have 7 protons. And again, if I know that protons are going to be the same as electrons so that I can have a neutral atom, I'm going to have a negative 7 electrons. So I have 7 electrons that are negatively charged. And here, I'm going to do the math portion again. The atomic mass is 14. I'm going to do it over here on this side. Okay, and that means that it has protons and neutrons combined. 14, the atomic mass. If I subtract that by the atomic number, which is protons, that's going to tell me the number of neutrons available. So here I have 7. Note that here, the mass is a little bit more different. I have an extra neutron. That's okay if your neutrons aren't the same as your atomic number. It just means that element's a little bit heavier with those neutrons. It doesn't affect the charge. It will later on affect the type of atom it is, but that's for another lesson. Here they just happen to all be the same, 7, 7, 7. 7 protons, 7 neutrons, 7 electrons. So I'm going to let you figure out how to do sodium on your own.